Okay, so what we're going to look at today is when we're dealing with these combination circuits. Now, what a combination circuit is when you've got both a series and parallel circuit in the same battery, basically. Now, as you can see here, when I can find the pointer, the current's going to leave this battery here. It's then going to go through, all the current has to go through this 5 ohm resistor, and then it gets to a point where it branches. So we've got a series meeting a parallel, okay, about half the current's going to go down each path. It's then going to join back up, and then it's going to be back in series with the 6 ohm resistor here. Okay, so what we're going to learn today is how to find any number of things inside a combination circuit. So you can find anything, and all we need to do is use Ohm's law and understand the difference between series and parallel circuits. So if we can do that, we should be able to solve it. But obviously, no one was born knowing how to solve these things, so I'm going to give you a bit of a tutorial. The first step to all of these problems, almost without fail, is to break it into components. And the first component I'm going to look at here, I'm highlighting in red here and calling it A, and that is the parallel part of the circuit. Okay, so we can't deal with the total series until we found out the resistance total of that part of the circuit. So I'm going to do my working here as best I can. I'm probably going to run out of room. But the first thing I need to do is find my resistance total for A. And the equation for resistance total in a parallel circuit is 1 over RT equals 1 over R1 plus 1 over R2. Those ones are a little bit different in size. And that is going to get me 1 over 7 plus 1 over 8, which I'm going to again use the cross multiply method. And that will give me 15, or 7 plus 8, which will be 15 over 56, which is 7 times 8. I'm going to try and undo that because that's a disaster. Okay, 15 over 56 is 1 over RT. I'm just going to create some more room. Therefore, RT will be the inverse of that, or when we flip it, which is 56 over 15. Okay, now I'm going to get my calculator out and figure that one out. As I don't know my 56 times tables off the top of my head. And I find that is 3.73 amps. So RT equals I'm just going to make that 3.7 ohms, not amps, sorry. 3.7 ohms. So that's all well and good, but now I need to find my total, because the first question is, how do we find the total current in the circuit? And the way to find that is to find the total resistance of the circuit. Now that I have a resistance total for 1, I can just consider it as a big parallel circuit. Okay, so I can call the green one B here. For B, again, I'm just going to put a little line across there. I might even go in red here because I think the black's going to be problematic over this side. For B, RT equals, zoom in here, R1 plus R2 plus R3, which is R2 or R3, whichever one you want, can be considered as our 3.7 amps, which is the total from the parallel before. So I get 5 ohms, plus 6 ohms plus 3.73, or 3.7 ohms. These are ohms for all of them. And I get that is 14.7 ohms. Okay, now we go back to Ohm's law. So again, I haven't used Ohm's law yet. I'm just using the resistance total for series and parallel. Now for Ohm's law, V equals IR. You can put VT equals IT plus RT or times RT. Doesn't bother me. I know my V is 10. If I go back over here, I can see my V is 10. I don't know what my I is. That's what we're trying to find out. Times 14.7. I then divide both sides by 14.7. And I find that my I equals, get the trusty old calculator out again, but this will be somewhere near 0.66, I would say. 0.68 amps. Okay, so 0.6 amps is the IT. Now, that's question 1 solved, and you can use that for any part of the. You could define the voltage in the first two. You would just go I times the R there. Okay, so if you wanted to find the voltage in 5 or 6, I can do that now. So we'll just do that now as a little side task here over here. So finding the voltage to the 5, I'll do the 5 ohm here. V equals IR. Okay, V, we don't know what V is. We know that I is 0.68 because it's in series, times my resistance 5. Okay, and that gives me an answer of 3.4. So 3.4 volts are used, of the 10 volts are used in, I'll go in the yellow, are used in that resistor. And you do the same thing again. I'll do it over here in, let's go blue, 6 volts, 6 ohms, sorry, not volts, 6 ohms. V equals IR, 0.68 times 6. And that gives me 4.08 volts. So in this resistor here, that's using 4.08 volts. This one's using 3.4. Now, that means the rest of the circuit is using just under 2.5, just over 2.5, 2.52 volts. So let's find out how more. We can go from there. We can find out that each resistor is going to be using 2.5. So that's one way of solving it. We can say that because these are in parallel, we know that they're going to have the same voltage. And if there's, we can go 10 minus 3.4 plus 4.08. And that will be 10 minus 7.48, which will give us 2.52 volts. So both of those use 2.52, but I can prove that. So I can prove that by do I need to prove that? No, I don't. I could find the current and then go from there, but that's just going to be a long way around. So that's how you find each component. Now, if we wanted to find the current through each one of those resistors, which we can do, I'll do that down here. So I'm just showing you a heap of different ways you can calculate different things. So let's have a look at the current going through the 7. And so I want to find out here, oh, I want to undo that. I want to find out, what colour haven't I really used yet? I want to find out how much current is going down that road and how much current is going down that road. So to find that out, I use this voltage that we've just found out before. Okay, so that's how much voltage. V equals IR, and you're just going to do this for both. So I'll start with the 8 ohm. Do you want to go, let's go red, just for something different. So for the 8 ohm resistor, V equals IR. Don't know the current, we know the voltage is 2.52. And then I, we don't know, times 8. Divide both sides by 8, of course, because we're good mathematicians and we don't like breaking the rules. I equals 2.52 divided by 8. 2.5. And we get 0.315. Now that should not ever be higher. This number here should never be higher than the total number of amps, which we found up here to be 6.8. Okay, and we'll do the same. I'll undo that because this is infuriating. We'll do this one here in, let's go back to black. This is the 7 ohm resistor. V equals IR again. Again, the same voltage because we're in parallel, 2.52. I times 7. Divide both sides by 7. Good little mathematicians. And we get 0.36. And again, it's always good to think. So we can call that I2 and I1, doesn't really matter. we always think with this, does that make sense? And when we add those two up, we should get something around 0.68, which it is. So I've just rounded this one, which is why they don't add up. But 0.315 and 0.36, when we add those together, we get 0.375, which is the same as a 3 point. If I didn't round, it'd be 0.68. Okay. So again, these are just tricks that you can find any number of things in a combination of series and parallel circuits. The main thing here is that you understand what happens in a series and parallel. You understand your equations. So for your parallel, remember 1 on RT equals 1 on R1 plus 1 on R2. For a series, R1 equals R1, RT equals R1 plus R2 plus R3, etc. Okay, and if you know that voltage stays the same in a parallel circuit and those sorts of things like that, these problems aren't too complicated. They get a bit long, but they're not very complicated. Keep your math strong, think about what happens in those circuits, and you should be fine with these. There will be a video coming at later stages, but make sure you practice. Practice makes perfect with these, and if you don't put in the practice, you're going to find them very hard and you're going to make mistakes. All the best, good luck. Peg.